Okay, so now that we've finished talking about the solar system, now it would be a good time to assign the big paper for the semester. It's not a big paper, but it's the most important kind of written assignment you guys have this semester. And this is called the NASA Mission Priorities Assignment. And the idea behind this assignment, well, just to give a little history, what I used to do when I taught astronomy 10 years ago, maybe even more, was I just make people do a little report about a space exploration mission. The Galileo mission to Jupiter, the Cassini mission to Saturn, the Voyager 2 probe, whatever. And that was an okay assignment, but it was kind of book reporting, and it didn't just mostly was students just looking up facts and regurgitating them. What I decided to do about 4 or 5 years ago was to create this assignment where you're being asked to do a little more thinking about space exploration, and not only what we have learned from various missions, but what we still need to learn about the various objects in the solar system. So the idea for the assignment is this. You're to imagine that NASA has only got enough money to fund one mission to solar system objects in the next, say, 5 years. And it's your job to choose among the candidate missions. And I've given you a list of potential missions that NASA is thinking about doing. These are all fake missions. They're not real missions. The point is to imagine if you had to choose one of these fake missions to the outer solar system or inner solar system or comet or asteroid, which one would you choose? Which one would you advocate for as being the most important? The mission that we would learn the most important things or most interesting things by spending our money on that particular mission. So the missions are listed in the assignment, and I'll post this assignment up to Canvas today. One is a sample return mission to Mars, a rover that will drive to Mars, dig up some soil samples, and dig up some rocks and ice, and bring them back to Earth. Several kilograms, about 2 cinder blocks worth of material from Mars, brought back to the Earth to be analyzed in the lab. And the rover will also stay behind and photograph Mars for up to 2 years. Number 2, a lander, which will land on Jupiter's moon, Europa. And this rover has a heated probe that is capable of melting into 1 meter of ice and can drive around on the surface of Europa taking photographs. The orbiting part of the spacecraft will continue orbiting Europa and also be able to photograph the other moons of Jupiter, Io, Callisto, and Ganymede. Mission 3, a mission to Saturn's moon Titan. And this mission consists of a trio of robots, a wheeled rover that can drive around on Titan, a quadcopter, a drone that can fly around on Titan in the atmosphere, and a small robotic submarine that can explore the bodies of liquid on the surface of Titan. Not liquid water, but liquid methane and ethane. The secondary part of that mission, the orbiting part of that, will be able to orbit Titan for an additional year and then shift over to orbit Saturn's moon Enceladus for another year. Option 4, a mission to Pluto and Charon. We have flown past Pluto and Charon, but we've never landed on it. So this mission would be to land rovers on Pluto and Charon. That will be similar to the Mars rovers that we've landed on Mars, can drive around and take pictures of stuff. And the flyby part of the mission will be that the probe will continue, after it drops off the rovers, will continue flying out into the Kuiper Belt and orbit the Kuiper Belt object Quaoar. Option 5 is an asteroid comet sample return mission where 2 identical probes will be sent, one to a comet, one to an asteroid, to sample material and bring it back to Earth. Now, since I wrote this assignment, there has been an asteroid sample return mission that they are still analyzing the results of. So you can talk about that mission. I believe that mission was called Hayabusa, but that's your job to research that mission. But we haven't analyzed the results yet, so this mission is still valid. We still do not have analysis of material returned directly from a comet or an asteroid. And those landers, after shooting the material back, will actually stay on the comet or asteroid and orbit around the sun for 1 whole year. Option 6, which I added just a couple years ago when we discovered some weird stuff about, well, let's say unexpected stuff about Venus atmosphere, is a Venus atmosphere mission. consisting of an orbiter that will orbit Venus and an atmospheric balloon that will float around in the atmosphere of Venus, produce high-resolution radar maps of the surface, and study the climate and the greenhouse effect and the composition of the atmosphere. You can assume that all of these missions share some features. They all have cameras that can take pictures. They all have the ability to measure the temperature of their surroundings. They all can measure magnetic fields and things like that. And they can measure the basic chemical composition of any material they come in contact with, whether that's liquid or gas or solid. So there's your missions. Your job is to pick the one that you think is the most important, the most compelling, the most interesting, and to write a short paper. What do we mean by short paper? This is the summer version is what I'm looking at right now, which says 1,500 to 2,000 words. Figure about a 2,000 word paper with references. Making your case for this mission. Now, how do you make your case? It is not just an opinion piece. You make your case by talking about what past missions to these objects have taught us. What have we learned from past missions to Jupiter and Saturn and Mars and Venus? And what unanswered questions remain about those objects that we could learn something from an additional mission with these additional parameters that we've never done before. So there's two parts to this. One is talking about the unanswered, well, one is talking about what we know about this object, what past missions have taught us. And two is talking about what unanswered questions remain and why they are important. Not just important to knowing about the object in question, but important to planetary science and astronomy in general. In other words, what do we serve to learn the most from? Okay, so that's the assignment. I will post it up to Canvas. Now that last time I gave this was a summer class. The summer class was very short. What I've done in the past few semesters, in the regular semester, is I've given you the opportunity to turn in a first draft. And I think I'm going to make that first draft mandatory. It was optional in the summer, but I think it's going to be mandatory for you guys. So I will post the due dates. I will post two separate assignments. One, the NASA mission assignment first draft, and two, the NASA mission assignment final draft. And you will have the whole semester that will be due at the very end of the semester. The reason for asking you to hand in a first draft is that I found that after the first few years of doing this that students tended to not do very similar things in their final paper. So after you turn in a draft, I will grade that. It won't be worth a lot of points, but I will give you comments and suggestions for improving that draft for the final draft. So you can think of the assignment as having two phases. You'll have a month or so to do the first draft, and then a couple of weeks for the final draft. If you have any questions, shoot me an email. I think the description is pretty clear. I may change the word count from 1,500 to 1,800, bump up the minimum a little bit, so have a look at that. There is also, as part, I think it's in the same document, there's also a rubric, which you should take a very close look at, because this tells you how I will be grading it. Based on your scientific rationale, how you explain the science involved and why it's important, what we have to learn from this mission, your explanations and coverage and description of past NASA missions to this object, how well written it is, whether your writing is clear and your grammar is correct, and that stuff is not worth as many points as the science stuff. And then just, did you turn it in on time? Does it meet the page requirements and so forth? So take a look at that rubric as well. And these dates are obviously from last semester. These are dates in April and May. I will update those dates when the first draft is due, when I will hand that back, and when the final draft is due. Okay, so I think that's enough of a description of that. I think it's a more interesting assignment than the old assignment, and I think it's something that'll give you a chance to pick one of these things that seems the most interesting to you and do a little research about it independently. All right, so I will stop this recording. I think it's recording. I hope it's recording, so I don't have to say this all again, and I'll post this up to YouTube today.